So, hello everybody. My name is Paula Dinerstein. I'm on the board of Beyond Pesticides, and also in my day job, I'm a lawyer for a group called Public Employees for Environmental Responsibility, or PEER for short. And I have the honor of introducing Dr. Jonathan Lundgren, who was actually a client of ours. We're basically an environmental whistleblower organization. And I don't believe that Dr. Lundgren set out to be a whistleblower. What he set out to do was to do good science. But his good science came up with some results that upset certain interests in industrial agriculture, and he found himself with his employer, the USDA, essentially turning against him. Until recently, Dr. Lundgren was a senior research entomologist and lab supervisor with the Agricultural Research Service, part of the USDA in South Dakota. He worked there for 11 years with great success. His research got national and international recognition. However, in April of 2015, he published a study in the Science of Nature which demonstrated that clothianidin, which is a neonicotinoid, killed the larvae of monarch butterflies in the laboratory. And some months later, on August 3rd, 2015, USDA imposed a 14-day punitive suspension on him for what we believed were the trumped-up charges of submitting that study to the journal and of certain what they called travel irregularities, minor discrepancies on his travel authorizations to travel to DC to address the National Academy of Sciences and a USDA stakeholder group in Pennsylvania, the No-Till Alliance. He filed a complaint of scientific integrity against the USDA. I mean, you may not know this because this is fairly new with the Obama administration, ordered all federal agencies to implement scientific integrity policies. They never had them before. So he filed a complaint under the scientific integrity process with the USDA, but it was rejected. And we now have a lawsuit challenging certain aspects of that policy which direct scientists not to say anything about their science that could impact policy. So this is where Dr. Lundgren got in trouble. If you want to read more about him, he recently, just within the last month or so, there was a cover story on the Washington Post weekly magazine that was entitled, "Was a USDA Scientist Muzzled Because of His Bee Research?" Beautiful beehive on the cover of the Washington Post magazine, and there was another article called "Whistleblower Might Add to His Complaint Against the Agriculture Department." So Dr. Lundgren is no longer with the USDA. He left recently and has begun some very new and exciting endeavors, which I think he will probably tell you some about. So it is my great honor to introduce Dr. Jonathan Lundgren.
All right, can everybody hear me all right? I tend to speak in the South Dakota wind, so my voice projects a little bit. First let me preface this presentation with saying that I frankly would not be here if it was not for PEER. And so I cannot say enough good things about what often happens and how PEER works is supporting scientists behind the scenes. And so you don't see a lot of the help that they give to scientists that need it. Scientists like me who never expected to be in a situation like this. I'm going to talk to you today. I'm not going to give you a lot of data this morning. I'll be talking more about the bee data that was suppressed at the pollinator session. So if you want to see the stuff that the USDA didn't want you to see, come to that one. But I'm going to talk today about risk assessment, and that's one of the things that I work on. That's one important aspect of what it is that of my research program, is trying to get at these very complex ecological questions underlying how we can assess risk reliably within a realistic context. And I think we saw a lot of that with Aaron Blair's presentation dealing with cancer especially there. But the other aspect of what it is that I do is trying to develop solutions to try to replace the use of pesticides using ecological principles, which probably would appeal to a lot of folks within the organic sector, but not necessarily just exclusively the organic sector. And so what a great meeting, huh? I mean, this is exactly the kind of meeting that we need to be having, is not just picking on, you know, oh, pesticides bad, but also providing solutions, because there is either a real or perceived need for these pesticides. And without filling that need using alternative methods, then really we're having a discussion that's not going to lead to solutions. 1948, Paul Mueller received the Nobel Prize for medicine. He discovered a chemical. The chemical was cheap to produce, had very low mammalian toxicity, and was blindingly effective at killing insects. This was a game changer, folks. It saved millions of lives because we started to use it, right? It tipped the balance into our favor, because prior to this, insects had really come to affect many, have serious deleterious effects on the human race, right? Insects have killed more soldiers than bullets or bombs have, okay? And until these early insecticides came along, diseases, human-transmitted diseases, literally turned the tides of war. We started spraying it in our houses, started spraying it in our wetlands. There was actually a World Health Organization, WHO-sanctioned mosquito eradication program for the entire planet, where we used DDT and like pesticides, the organochlorines, organophosphates, to try to eradicate mosquitoes from the face of the earth. It did not work, by the way. It did not work. Nevertheless, we used it without thoughts of consequences, because now we had a tool. Farmers no longer had to think about things as far as insect management was concerned. They could simply react as a pest problem became problematic, right? But there were concerns. There was problems that started to arise. Many of these we're still uncovering today. There were harmful environmental effects. We're still finding DDT in tissues, even within human populations. Large apex predators were eliminated, some driven to near extinction, based on, or because some of these organochlorines weaken the eggshells of the birds, and they bioaccumulated such that they were present at highest densities within some of these large predators. Incidentally, we're starting to see declines again in some of these large raptor populations. Some of my friends in the wildlife department in South Dakota State just revealed that information to me. So we're starting to relive some of these things that we experienced many years ago. And of course, there were a lot of human health problems. Not just cancer, but also birth defects, diabetes, brain damage, all linked to some of our pesticide use. And to add insult to injury, the pests themselves became resistant to the actual use of these things. Because insects are good at that, right? High reproductive rates, quick adaptability to strong selection pressures within the environment. Are these chemicals inherently bad? Should Paul Mueller have received the Nobel Prize for medicine? I think it's easy to look back through history and say, now we have information that says that there were some serious problems with the use of DDT. At the time, using the best technology of the day, the questions that we were asking in our risk assessment procedures suggested that this was a safe chemical. Does that mean that all of these chemicals are inherently bad? Or should we presume that there are problems with them and use them as needed, right? More of a precautionary approach. Because no matter what decision we make, there are costs and benefits to everything, all right? Even doing nothing at all has a cost and a benefit. The question is, how do we measure these costs and benefits effectively? That is the question. That is a very important issue. Because, because ecological risk assessment is really hard. We are trying to prove a negative. And just like Albert Einstein said, proving a negative is only, I mean, we can, as we devise hypotheses to test, all it requires is a single example, switching the question around in order to reveal that our presumption of safety was erroneous all along. And so we rely on a preponderance of evidence. But once again, the preponderance of evidence is only as strong as the questions that we are asking with our risk assessment. It's only as strong as our technology allows us to measure risks in the environment. A great question is BT crops. Do they pose an extraordinary risk to the environment? BT crops, this is for those of you who do not know, this is a genetically modified crop. It has a gene from entomopathogen, an insect disease, that it expresses from root to pollen. And it tends to be fairly specific for particular insect groups, especially the key pests of the crop plant in general, or of the crop plant itself. This was really a game changer in terms of risk assessment from the environmental standpoint. Human health may have a much different history here. But genetically modified crops, whether you love them or hate them, they're here, and there is a lot of public interest in ensuring their safety, because there's a lot of fear that's associated with genetically modified crops. Frankenfood, things along these lines. Should we be genetically manipulating and inserting foreign genes into our food production system? So there was a real, this was all waged, this war was waged in the public, and it was driven a lot by the monarch butterfly, to be honest with you. But what BT crops really represented was a paradigm shift back to a prophylactic pest management strategy. For a number of years, after the EPA was devised and integrated pest management came forward, what ended up happening is that farmers started to go out into their fields and sample. And they only used pesticides when they had a pest problem. And so what happened with BT crops is by putting all of the insecticide right in the bag, the farmers no longer had to think about it anymore. They were investing in that pest management strategy whether or not they needed it, which is a bad business decision. I mean, we know that, right? That's a bad business decision. If you know you're going to have a pest problem annually, then maybe it's worth the investment. However, this was a slippery slope because it opened the door for a lot more prophylactic pest management. Okay, so risk assessment. It's only as strong as the questions that we ask. So are pesticidal BT crops toxic to non-target organisms? Non-humans here, okay? We're talking about the environment. Also, do BT crops reduce the abundance of non-target organisms in the field? And abundance is a proxy for all kinds of different fitness effects, right? because you could have reduced fecundity, or reproductive rates could be reduced. It could be longevity. It could be outright mortality. It could be dispersal. All of these things should be housed within this one proxy of abundance in the field, arguably. We have data from this. We have a lot of data from this. We have hundreds of published studies in this system. So I was actually a part of this meta-analysis looking at those effects of Bt crops on non-target arthropod abundance in the field. This was done on cotton, Bt corn, and Bt potatoes. And these are the different functional groups of insects that we examined. Predators, things like lady beetles, parasitoids, these are largely wasps. These are things we just couldn't figure out what the hell they're doing out there. This is herbivores eating plants. This is omnivores. This is eating both plants and insects, and these guys are the soil dwellers. And what we found is that the baseline here is the untreated control. This means no treatment decision. And if it's reduced, if Bt crops reduces that particular group, then you would expect to see the bars to go down below. But if the error bars go over the line, doesn't count, okay? So what we find is that parasitoids are reduced in corn largely because of a bunch of studies that all studied the primary parasitoids of the European corn borer, which were eliminated based on Bt corn. You see there's a general reduction, but none of it's really significant except for predators and cotton. And down here, potatoes, you actually saw an increase in some of these predators, a very slight increase in some of these insect groups. We also looked at it relative to insecticides because there's a cost and there's a benefit to every decision, right? And if Bt is not used, then it's possible that insecticides would be used to replace that, okay? And what we find is that in this case, Bt crops almost always is better than the insecticides that they're supposed to be replacing. Except for, oddly enough, omnivores and detritivores. These are colembala, little springtails that are jumping around in the soil, are actually reduced more by the, in corn systems by the Bt than versus the insecticide use. All right? Based on the available data, Bt crops seem to have a minimal toxicological effect on non-target organisms in the laboratory as well. All right? So I qualified that. I threw the caveat based on the available data because there are studies that have been suppressed that show an adverse effect. In fact, I wrote one of them. So, the published literature, is there a file drawer effect based on that these meta-analyses may not be capturing? Very possibly. Is toxicology the risk that we're worried about? There are some exceptions. Specialist natural enemies. This is a parasitoid wasp. Instead of stinging people, these wasps are actually the most diverse group of animals on the planet Earth. Instead of stinging people, they lay their eggs. They use their stingers to lay eggs inside of other insects. So it's like the movie Alien, where the larva develops inside of this host. It's really cool stuff. I mean, this is going on in your backyard, folks. Really neat. Certain spider families seem to be reduced by Bt. And then things like trichopterans, these are caddisflies, they actually build this house. You can buy earrings based on of jewelry based on these. Oh, they're so cool. You have them? Yeah, all right. So as Bt crops, one of the claims to fame is that it has reduced insecticide use. This is now, I believe, and hopefully been debunked. Not because Bt crops require additional insecticide use, but because, and we wrote one of these studies too, I'm not sure, yeah, there it is. But because The paradigm shift that was associated when people started to use Bt crops with prophylactic pest management accompanied an increase in marketing and sales of other insecticides that could be sold along with this new marketing strategy. And so we actually see that neonicotinoids are now used on the majority of cropland acres. I have a great slide that I often show, and it happens to be one I plucked out, of corn, soybean, and cotton plantings, and it almost exactly mimics the one that we saw with the leukemia incidence rate in some of the. It was remarkable when I saw that other graph. I'm like, is that my slide? It's suggesting that there is a strong correlation, not just but not possibly causation. But there would need to be additional information or data gathered on that. Regardless, insecticide use is rising. There is bad data from the National Agricultural Statistics Service because they are not capturing the seed treatment use as well as some of these other chemicals. Okay? Bt crops have been associated with the simplification of our land use, okay, of our food production systems. Because the ethanol mandates that were put forward in 2007 necessitate a certain proportion or a certain quantity of ethanol be produced by plants. Corn is the only realistic source of this ethanol. And so it has artificially increased the value of corn and resulted in more farmers abandoning other crop management strategies to focus exclusively on corn, as well as increasing corn acreage and taking non-crop habitat and planting it with corn. And that's only possible with Bt corn, because you can only plant corn after corn after corn using this transgenic, otherwise the pests just overcome you. So the question is Bt crops safe? If we're asking the question, are Bt crops toxic? The answer is probably no. Are we asking the question, has Bt crops changed the natural environment in which we're living and increased our exposure to other insecticides? Perhaps not directly, but they have been associated with this major change, okay? These are normal-sized people, by the way. These aren't like midgets that are, they're pretty short, I'm not gonna lie. But it is like 18-foot tall corn. But you look at the soil upon which it's planted, it's dead. It's just dead. Silent Spring, man, that was a great play last night. Were you guys all here? That was amazing. I really liked that. Silent Spring identified a critical problem, and it was so influential. And the results and the impact that this has had on our entire society and our whole perception of the natural environment is profound. I think we now, at least personally, I don't think it went far enough, because the problem is that pesticides aren't the problem here. We're focusing so much. Let's get rid of these pesticides. Let's point out all of the problems with the pesticides, right? But you know what? Even if we banned all pesticides tomorrow, we're still going to have the same issues that we do today, because this is not a pesticide problem. This is not a bee problem. This is not any of these problems. This is a problem with our food production systems. And until we revise, reform, transform our food production systems away from the simplified monoculture model, we are not going to solve these issues. That's what makes this meeting so special. Let's figure out what causes pest problems to begin with, rather than always reacting to the symptoms as they start to outsmart us. If we manage a healthy ecosystem, folks, these pests are just not an issue as much anymore. That doesn't mean what I'm getting up here and saying is abandon all pest management principles. Ignore your pests. No, that's not what I'm saying. But what I am saying is that if we use some very simple conceptual ideas, that we can dramatically reduce our reliance on pesticides. Profitably. Reduce disturbance, increase diversity in our food production systems. Reduce disturbance. That kills soil. That kills the biology in soil. Step one in this process is to reduce or eliminate or reduce tillage. That soil biology is the basis upon which our food production systems relies. When you do this, you extirpate all of the natural biotic resistance to pest proliferation. You come in, you plant thousands of acres of a single plant species that is genetically limited to producing a large seed that we like to eat. The primary pest is the first insect that arrives. It no longer has any biotic resistance to its proliferation, and so you must replace biodiversity with a chemical. That is the pesticide treadmill in a nutshell, okay? Starts here. It starts here. The next thing, energy gets into your system via photosynthesis. Photosynthesis is produced by plants. We need more vegetation diversity within our food production systems in order to feed the rest of the biodiversity in that system. And there are agronomically proven ways of doing this. In South Dakota, we have the corn, snow, corn rotation. That is not diverse enough. That is not diverse enough. The science is clear on this, okay? We need to be extending these out 4 or 5 year rotations, oftentimes with a perennial phase. That is the most resilient and profitable rotation in the long run of food production systems. Intercropping, when you have 30-inch rows, you have 30 inches of bare soil. We need to be filling that up. We need to be feeding that. We need to be capturing that energy down into the soil. We need to be using cover crops in the fallow period. We need to be covering that soil. Always having a bare root out there, or having a living root out there, We need to be having roots in our soil. We need to be connecting growing seasons so that we don't extirpate the biology from that system. Field margins, conservation strips, these are tools for us. Weeds have a role to play. A zero-tolerance policy towards weeds is not okay. The most amazing thing is that as I started to ask these questions, I'm traditionally trained as an entomologist, that reacts to pests, right? That's how I learned. But I always questioned in the back of my mind how this procedure went, and then I started to interact more with farmers that are doing things differently. In Colorado, they are growing potatoes, which is an insecticide-intensive crop. Those of you of Maine probably know this. They're growing it without insecticides, this guy is. He's taken it's drier there than here. They have, so they irrigate, he uses his pivot corner, so for conservation strips. He actually plants flowering covers into his potato rows while planting, large seeded stuff, so that he can plant it deep and it'll come up. And then he's eliminated one phase, the barley phase of his rotation, and instead of having that second crop, he plants a green manure that he then grazes. And by taking that second crop out of the rotation, he's actually increased the profitability of his long-term operation because he no longer needs fertilizers or insecticides during the potato phase. So he's looking at things rather than just at a single season at a time. There he is right there. That's Brendan Rocky in Alamosa, down in the San Luis Valley. He hasn't used insecticides in 20 years. Dwayne Beck, Bismarck, North Dakota. Man, Burleigh County, North Dakota, there are so many cool things going as far as regenerative ag is concerned. It's really profound. He hasn't used insecticides in 26 years. Occasionally, Dwayne Beck will. You look at no-till adoption in the Great Plains, there's a big swath of it. Dwayne Beck is right in the center. Oh my goodness, what just happened? All right. I don't know what just happened, and I have no keyboard. Wait a minute. Something's good. All right, there we go. Dwayne Beck doesn't use insecticides. He will use BT simply because he can't find corn seed that doesn't have it. Has trouble with that. Gail Fuller, no insecticide. Dave Brandt, they've actually, he's got his own soil type. He's changed his soil over the last, few decades using no-till and covers, that he now has a soil type that has never been defined before on his farm. When asked, I was having breakfast with him, I asked him, when's the last time you used insecticides? He said, it's been about 7 years ago. Like, all right. And he's like, except for that one 10-acre field. And I asked him, well, why do you do that? He's like, I put a seed treatment on, a neonic. And he says he puts it out there because his agronomist told him that all of his neighbors get like a 6-bushel yield bump. This isn't corn. I'm like, do you see that? He's like, no, I actually see a 9-bushel yield drag. And I'm like, well, why do you do that then? And he's like, well, to prove that my agronomist is full of crap. Every year, he's full of crap. Because when you change the soil, when you restore the soil's biology, you find that it doesn't behave by the same rules anymore. The same rules do not apply any longer. This talk was about pollinators. I will tell you the solution to the pollinator crisis. It ain't about varroa mite. It ain't about the diseases. It's not about the pesticides. Right there. That's your solution. It's very simple. Okay? Because these issues aren't just a bee problem. This is a biodiversity crisis that we are facing right now. We've lost wetland habitats. Entire habitats are diminishing rapidly, okay? We're currently living in the Holocene extinction event, which is one of the most severe extinction events that the planet Earth has ever experienced throughout geologic history. The data is pretty clear on this. We are losing species at a rapid rate. Where'd the prairie go? Insect communities are being lost. Butterflies, birds, bats. Come on, wake up, let's connect the dots. All right. So to sum up, a little bit about science. It's our job to ask questions. Sometimes the answers to those questions are inconvenient, but throughout history, whenever we've asked, or scientists have challenged the current paradigm, if the paradigm is big enough, that scientist tends to experience problems. Be it, some of these, where we fit in the galaxy, or within our solar system even. The continents, move on plates. Jumping genes, McClintock, we've got Alan Turing, there's a movie's written about him. Lynn Margulis, with symbiosis, challenged the very premise of evolution and how speciation occurs. These people were all ostracized, right? My kids and I were watching Cosmos, the new one with Neil deGrasse Tyson. And it talks about the history of science and discovery and things like this, and like every damn episode. It's like, so-and-so, he found out that light, refracts in a different way. And this was so important for us discovering, the nature of the stars and developing new telescopes, and they chopped his hands off and burned him at the stake. It's like, what the hell? My kids are like, this is professional science? Every episode. You're right. Rachel Carson is, we learned about that last night, so I'm not going to belabor that, but certainly is a great example, right? But she persevered. And perseverance like that is so important as far as advancing our society. The formation of the US EPA, the FIFRA, that's all related, I mean, to this lady who was ostracized. So I've asked the question of myself over the years, and that's a very young John. I have hair there, more of it, less wrinkles, less bags under my eyes. I've had to ask myself the question this many times over the last few years. I went from being one of the golden boys of science. I was elected one of the top young scientists in the country. I got to meet Obama in the White House. And then the farmers and the beekeepers were seeing things in their operations that oftentimes defied science or was exactly contrary to science. They were doing things that on their farms that science said couldn't happen. They were seeing effects of pesticides that science was saying wasn't happening. And so I decided to devote my expertise to answering those questions. And those questions question the current paradigm of food production. And so I've had to ask why the shift from golden boy to pariah within the USDA? Was it because of the questions? Was it because I changed the way I was presenting it so that people would actually understand what it is that I was trying to say? And I don't know. I think ultimately it comes down to fear. There's a lot of fear within the USDA. And that fear prompts good people to do bad things. And I can get up here and I can tell you, all of those things that you read on dorm room posters, integrity and perseverance and strength. And, there's a picture of a whale and shit like that. And I can get up here and I can tell you that that's the motivation or the driving factor behind blowing a whistle like I did. But there's always an element of doubt. And what was the motivation behind, because I think motivation behind making a disruptive decision as I did is really important. Because there's consequences, right? I mean, I threw away a very, very long and comfortable and promising career with the USDA based on my decision. And everybody that I care about in my life was hurt because of my decision. Friends don't talk to me anymore. People that I care about despise me because I made this decision. But then, on the flip side, there's also fine people like yourselves, and the support has been very strong, and I do appreciate that. But I don't hold it against anybody for not wanting to go this route, because there are a lot of scientists that have been in the same place as I was and am that didn't make this decision. And part of the reason I ran into so much trouble is because they didn't stand up to the tremendous pressures that you end up going through by going this path. In fact, on Thursday morning, I met with a colleague, and he's like, I've just resolved to say that part of my annual duties is to make my boss look good. That's part of my scientific duties now, as working for the USDA. And yeah, it bothers me, but at the same time, his motivation is that he has a family at home, and he's got, you know, people in his lab that are depending on him to fund, you know? So, what is my motivation? Yeah, right there is two really good reasons, and these are my kids, but it's also for yours. I believe that the only way that we can really solve some of these planetary scale problems is by having open and respectful discourse on some of these issues. Thank you. In seeing a lack of scientific support for the people that are trying to innovate our food production systems, I've taken a new path. We have devised a nonprofit, Ecdysis Foundation. These are the two websites. Ecdysis is metamorphosis, shedding the old skin in insects. It's a geeky entomological term that's very applicable. Blue dasher is a dragonfly species. As such, it constitutes a cool bug. People can identify with that. We are starting an initiative Centers for Excellence in Regenerative Farming Principles that we hope to establish a nationwide network where we pair cutting-edge research and science with education, training the next generation of scientists and farmers, and demonstration, where we show, because seeing is believing. That is what we are doing right now. The farmers and the beekeepers, we said, if you believe in this, consider supporting it, and they did. They bankrolled a research lab. I don't believe that's ever happened before. So if this is something that you believe in, please consider supporting it. Because we need to figure out how to solve this, how to crack this nut. 35% of our terrestrial land surface of our planet is food production systems. That means conservation of species needs to happen and involve farmers, okay? No good scientist is up here and able to present without the tremendous support of a fine group of young and enthusiastic scientists, okay? These are, my research team is fantastic. A lot of them are coming with me to the new Blue Dasher Farm Initiative. So, yeah, if I wasn't here right now, I'd be at home building beehives, getting the farming operation up and running, and getting the lab all built up. So, we're actively getting going. We've been open for about a month and a half now. All right, that's all I got. That was a lot.